Hi everyone, I am K.Kavitha, Assistant Professor of Computer Science, A.D.M. College for Women, NAGAPATTINAM. Today we see about JSP. Introduction to JSP. JSP means Java Server Page. It is a technology used for developing dynamic web pages in Java programming languages. JSP is built on top of the Java Servlet API and it is an integral part of Java's extensive web development ecosystem. Java Server Page allows developers to create web pages that combine static HTML with dynamically generated content using Java code. JSP achieves this is by embedding Java code directly within HTML using special JSP tags. This approach enables the creation of rich, interactive web application that can respond to user input and interact with server-side resources. It is an advanced version of Servlet. It provides enhanced capabilities for building scalable and platform-independent web pages. How is JSP more advantageous than Servlet? JSP simplifies web development by combining the strength of Java with the flexibility of HTML. Some advantages of JSP over servlets are listed below. JSP code is easier to manage than Servlet as it separates UI and business logic. JSP minimizes the amount of code required for web applications. It generates content dynamically in response to user interactions. It provides access to the complete range of Java API for robust application development. JSP is suitable for applications with growing user bases. Features of JSP. It is the platform independent. We can write once, run anywhere. It simplifies databases, interactions for dynamic content. It contains predefined objects like request, response, session and application, reducing development time. It has built-in mechanisms for exception and error management. It supports custom tags and tag libraries. JSP architecture. JSP follows a three-layer architecture: client layer, web server layer, database backend layer. First one, client layer. The browser sends a request to the server. Server layer. The server processes the request using a JSP engine. Database and backend layer means it interacts with the database and returns the response to the client. JSP runs in two phases: translation phase and execution phase. In translation phase, JSP page is compiled into a servlet which is called JSP pager implementation class. In the execution phase, the compiled JSP is processed. This is the architecture of JSP: client, server and database. What are the differences between JSP and Servlet? Features: JSP and Servlet. Code length. JSP requires less code. Servlet requires more code. Ease of use. JSP is simple to use. Servlet is more complex to use. Dynamic content. JSP easily embedded in HTML. Servlet requires HTML generation in code. Page maintenance. Easier to maintain. Servlet more challenging. Core components of JSP architecture. The architecture of JSP is composed of several key components, each playing a crucial role in the generation and rendering of web pages. First one, JSP page. It is essentially an HTML page embedded with Java code. The embedded code can include expressions, scriptlets and declarations, all enclosed within special tags. JSP pages are typically saved with a .jsp extension. JSP tags. Second one, JSP tags are specially syntax elements that enable the inclusion of Java code within HTML. The most common tags are expression, scriptlets. First one, expression. evaluate and output the result of a Java expression. Scriptlet, it embeds Java code that executed when the page is requested. Declaration, which is declared variables and methods that can be used within a JSP page. Directives. Directives provide global information about the JSP pages. They are used to import packages, define page level settings, and include other files. There are some common directives includes page directive, include directive, tag live directive. First one, page directive. It defines page settings such as content type, error pages, and session management. Include directive, it includes the content of another file at page translation time. Tag library declares a tag library to be used in the JSP page. JSP action tag. Action tags are predefined tags that perform specific tasks such as forwarding requests or including other resources. Some common tags include JSP forward, that means forward the request to another resources. JSP include, which include the content of another resource at request time. JSP param adds a parameter to a request. Expression language, that means it simplifies the access of data stored in Java beans, components, collections, and other objects. Here expressions are enclosed within dollar symbol and braces, and which are evaluated at runtime. EL provides a conscious syntax for accessing properties, invoking methods, and performing operations. Java beans. Java beans is nothing but it is a reusable Java components that encapsulate data and behavior. In JSP, Java beans can be used to store and manipulate data. They are typically accessed using EL or custom tags. Custom tags and tag libraries. Custom tags are user-defined tags that encapsulate reusable functionality. Tag libraries do custom tags into reusable collections. The Java Server Pages standard tag library is a widely used tag library that provides common functionalities such as iteration, conditional, and internationalization. JSP lifecycle. The lifecycle of a JSP page involves several stages from the initial request to the final response. Understanding this lifecycle is crucial for optimizing performance and ensuring proper resource management. Translation. When JSP page is requested for the first time, the JSP container translates the page into a Java servlet. During this phase, the container parses the JSP syntax and generates the corresponding servlet code. Compilation. The translated servlet code is then compiled into a Java bytecode classes. These steps ensure that the JSP page can be executed by JVM, that is Java Virtual Machine. Initialization. Before serving the first request, the JSP container initializes the servlet by calling its init method. This method can be overridden to perform any necessary setup, such as initializing resources and setting configuration parameters. Execution. Execution means for each subsequent request, the JSP container invokes the service method of servlet, which processes the request and generate a response. During this phase, the embedded Java code is executed and dynamic content is generated. System cleanup. When the servlet is no longer needed, the JSP container calls it destroy method to release any resources and perform cleanup tasks. This setup ensures that servlet does not consume necessary resources when it is no longer in use. What are the advantages of JSP? JSP provides several features that make it a powerful tool for web development. First one, separation for concerns. JSP promotes the separation of concerns by allowing developers to separate their presentation logic from the business logic. This is achieved through the use of Java beans, custom tags and tag libraries which encapsulate business logic and data access. Cleanup. When the servlet is no longer needed, the JSP container calls it destroy method to release any resources and perform cleanup tasks. These steps ensure that the servlet does not consume unnecessary resources when it is no longer in use. JSP development. To ensure the development of robust and maintainable JSP applications, developers should adhere to several best practices. Use MVC architecture. Implementing the model view controller architecture separate the presentation layer from the business logic and data access layers. This separation promotes a clean and maintainable code base, making it easier to manage and extend the application. Minimize Java code into JSP pages. Embedding exclusive Java code within JSP pages can lead to complex and hard to maintain code. Instead, use Java beans, custom tag and tag libraries to encapsulate business logic and data access. Leverage tag libraries. Tag libraries such as JSTL, which provide common functionality and promote code reuse. Leveraging these libraries can simplify JSP development and reduce the amount of a custom code required. Use expression language. Expression language provides a concise and readable syntax for accessing data and invoking methods. Using EL can improve the readability of JSP pages and reduce the need for complex Java code. Optimize performance. To optimize the performance of JSP applications, developers should minimize the use of expensive operations such as database queries and file I/O within JSP pages. Instead, perform these operations in the business logic layer and pass the result to the JSP pages for rendering. Related technologies. Java servlet. Java servlets are foundation upon which JSP is built. Servlets handle HTTP requests and generate responses, providing the core functionality for web application. JSP abstracts the complexity of servlets by allowing HTML and Java code to be mixed, simplifying the development processes. Java server face. Java server faces, which is a component-based web framework that simplifies the development for user interface for web applications. While JSP follows a page-centric model, JSF uses a component-based architecture, providing a more structured and modular approach. Spring framework. The Spring framework is a comprehensive framework for building enterprises applications. It provides extensive support for web development through Spring MVC, which can see as an alternative to JSP. Spring MVC follows a more flexible and lightweight approach, often preferred in modern web development. And also Java EE. Java EE means Java Enterprise Edition, which is a platform for building large-scale enterprise-level applications. It includes a wide range of technologies such as EJP, JPA and CDI that can be used in conjunction with the JSP to build robust and scalable web applications. Next topic is JDBC, Java Database Connectivity. It is an API that helps applications to communicate with databases. It allows Java programs to connect to a database, run queries, retrieve and manipulate data. Because of JDBC, Java applications can easily work with different relational databases like MySQL, Oracle, PostgreSQL and more. JDBC architecture. This is the diagram of architecture. Application, JDBC app, JDBC drive manager. Application means it can be a Java application or servlet that communicate with the data source. JDBC API means it allows Java programs to execute SQL queries and get results from the database. Some key components of JDBC API include interface like driver, result set, row set, preferred statement and connection that helps managing different database tasks. Classes like drive manager, types, clause that helps managing database connections. Driver manager. It plays an important role in the JDBC architecture. It uses some database specific drives to effectively connect enterprise applications to databases. JDBC drivers. These drives handle interaction between the application and the database. Architecture consists of 2-tier and 3-tier process models. First one, 2-tier architecture. A Java application communicates directly with the database using a JDBC driver. It sends queries to the database and then the result is sent back to the application. For example, in a client-server setup, the user system acts as a client that communicates with the remote database server. In this structure, syntax client application, JDBC driver and database. 3-tier architecture. In this, user queries are sent to middle-tier services which interacts with the database. The database results are processed by the middle tier and then sent back to the user. Structure, client application, application server, JDBC driver and database. JDBC components. There are generally 4 main components of JDBC. JDBC API. It provides various methods and interfaces for easy communication with the database. It includes 2 key packages, Java and SQL. This package is the part of Java Standard Edition, that means Java SE, which contains the core interfaces and classes for accessing and processing data in relational databases. It also provides essential functionalities like establishing connections, executing queries and handling result set. JavaX.SQL. This package is the part of Java Enterprise Edition, that is Java EE, which extends the capabilities of Java.SQL by offering additional features like connection for pooling, statement pooling and data source management. JDBC Driver Manager. Driver Manager is responsible for loading the correct database specific driver to establish a connection with the database. It manages available drivers and ensures that right one is used to process user requests and interact with the database. JDBC Test Suite. It is used to test the operations, that means such as insertion, deletion, updating being performed by JDBC drivers. JDBC drivers. They are client-side adapters that convert requests from Java program to a protocol that the DBMS can understand. There are 4 types of JDBC driver: Type 1, Type 2, Type 3, Type 4. Type 1 means Type 1 driver are JDBC, ODBC bridge driver. Type 2 driver native API driver, partial Java driver. Type 3 driver are network protocol driver, fully Java driver. Type 4 driver are thin driver. It is a widely used driver. The old drives like JDBC, ODBC bridge driver have been deprecated and no longer supported in modern version of Java. JDBC classes and interfaces. Classes and interfaces description. Driver manager, which manages JDBC drivers and establishes database connections. Connection, which represents a session with a specific database. Statement, which is used to execute static SQL queries. A preferred statement, which pre-compiled SQL statement used for dynamic queries with parameters. Callable statement, which is used to execute stored procedures in the database. Result set, which represents the result set of a query, allowing navigation through the rows. SQL exception, handles SQL related exceptions during database operations. JDBC allows Java application to perform the following: connect to a data source, send SQL queries and update statement to the database, retrieve and process results for the database. Structure of JDBC driver. JDBC driver structure illustrates the architecture of JDBC driver, where an application interacts with the JDBC API. The API communicates with the JDBC driver manager, which manages different database drivers, example SQL Server, Oracle to establish database connectivity. JDBC ODBC bridge driver, it is a type 1 driver. They are connected to the database. The JDBC ODBC bridge driver converts JDBC method calls into the ODBC function calls. Advantages: this driver software is built in within JDK, so need to install separately. It is a database independent driver. Disadvantage: as a common driver is used in order to interact with different databases, the data transferred to this driver is not so secure. The ODBC bridge driver is needed to be installed in the individual client instance. Native API driver is the type 2 driver, which is uses the client-side libraries of the database. This driver converts JDBC method calls into native call of the database. In order to driver needs the local app that's why data transfer is more secure as compared to type 1 driver. This driver is not fully written in Java, that is why it is also called partially Java driver. Advantage: a native API driver gives better performance than JDBC ODBC bridge driver, which is more secure compared to the type 1 driver. Disadvantage: drivers need to be installed separately in individual client machines. The vendor client library needs to be installed on client machine. Type 2 driver isn't written in Java, that's why it isn't a portable driver. It is a database dependent driver. Network protocol driver, it's a type 3 driver. The network protocol driver uses middleware that converts JDBC calls directly or indirectly into the vendor specific database protocol. Advantage: type 3 drivers are fully written in Java, hence they are portable drivers. No client-side library is required because of application server that can perform many tasks like auditing, load balancing, logging, etc. Easy to switch databases. Disadvantages: network support is required on client machine, which is maintenance of the protocol driver because costly because it requires database specific coding to be done in middle tier. Thin driver is a type 4 driver. It is also called the native protocol driver. This driver interacts directly with the database. It does not require any native database library. That is why it is also known as thin driver. Advantage: does not require any native library and middleware server, so no client side or server side installation. It is fully written in Java language, hence they are portable drivers. Disadvantage: if the database changes, a new driver may be needed. When we use which drivers, if you are accessing one type of database such as Oracle, Sybase or IBM, their preferred driver type is type 4. If your Java application is accessing multiple types of database at the same time, type 3 is the preferred driver. Type 2 driver are useful in situations where type 3 or type 4 driver is not available yet for your database. Type 1 driver is not considered a deployment level driver, which is typically used to deployment and testing purposes only. Establishing JDBC connection in Java. Before performing any database operations, you first need to establish a connection using JDBC. This connection acts like a communication channel through which SQL queries are sent and results are received. Setting up this connection involves loading the database's driver, specifying the database URL, and authenticating with the username and password. Steps 2. Establish a JDBC connection. Import the package. Second, step 2, load the drivers using the codename of method. Step 3, register the drivers using driver manager. Step 4, establish a connection using the connection class object. Step 5, create a statement. Step 6, execute a query. Step 7, close the connection. Types of statement in JDBC. In Java, the statement interface in JDBC, which is used to create and execute SQL queries in Java applications. JDBC provides 3 types of statements to interact with the database. That is statement, preferred statement, callable statement. First one, statement. A statement object is used for general purpose access to databases, and it is useful for executing static SQL statement at runtime. Syntax: statement equal to connection.create statement of. Once the statement object is created, there are 3 ways to execute it. Execute string SQL. It is used to execute any SQL statements like select, insert, update, or delete. If the result set object is retrieved, then it returns true, else false is returned. Execute update. It is used to execute SQL statement like insert, update, or delete. It returns the number of rows affected by the SQL statement. Result set. Execute query. It is used to execute the select query. It returns a result set object that contains the data retrieved by the query. Second one, preferred statement. It represents a pre-compiled SQL statement that can be executed multiple times. It accepts parameterized SQL queries with question mark as placeholders to parameters which can be set dynamically. Implementation. Once a preferred statement object is created, there are 3 ways to execute it. Execute up. This returns a boolean value and execute a static SQL statement that is present in the preferred statement object. Execute query of. This returns a result set from the current preferred statement. Execute update. This returns the number of rows affected by the DML statement such as insert, delete, and more that is present in the current preferred statement. Callable statement. It is used to execute stored procedures in the database. Stored procedures are pre-compiled SQL statements that can be called with parameters. They are useful for executing complex operations that involve multiple SQL statements. Syntax: callable statement equal to connection prepare call of call procedure name. Call procedure name calls a stored procedure name with placeholder for input parameters. Methods to execute: execute of. Execute the stored procedure that return a boolean indicating whether the result is result set or on update count false. Execute query: execute a stored procedure that return a result set. Execute update of. Execute a stored procedure that perform an update and return the number of rows affected. Thank you.